Okay, good morning all of you. We are discussing about the relation between partial pressure and total pressure. So already previously we derived a partial pressure of A gas is equals to number of moles of A gas into RT by V. Like that, partial pressure of B gas is equals to number of moles of B gas into RT by V. Then total pressure also we derived in the previous class NA plus NB into RT by V. Yes or no? Yes. Now I want to get the relation between partial pressure and total pressure is a very important thing. See carefully, partial pressure of A gas by total pressure is equals to number of moles of A into RT by V by N of A plus N of B into RT by V. RT by V cancel will come. So then we are getting partial pressure of A by total pressure is equals to N of A by N of A plus N of B. Yes, this is similar to number of moles of A component by total moles is calling as a mole fraction. We'll learn in the first topic at last. Okay, then we are getting partial pressure of A gas by total pressure is equals to mole fraction of A. That implies partial pressure is equals to mole fraction of that component into total pressure we are taking. Is clear? Yes. Now we are getting, this is the one relation we are getting, and another relation PB. Partial pressure of B gas by total pressure. What we are getting among? N of B by RT by V by N of A plus N of B into RT by V. RT by V cancel. What you are getting? PB by partial pressure of B gas by total pressure is equals to number of moles of B component by total moles is nothing but mole fraction of B component. That implies partial pressure of B gas is equals to mole fraction of B gas into total pressure we are taking. Yes or no? Yes. Now we are proving that Dalton's law. How you got? Just once you take it, LHS we are taking PA plus PB, partial pressure of A gas plus P gas. So what we are getting? PA is nothing but chi A into total pressure. PB means chi B into total pressure. So then what we are getting? P total is a common amount. P total is a common. After that what we are getting? Chi A plus chi B we are getting. Already learned in the first topic, some of the mole fractions of all the components should be 1. Then what you are getting? Here 1 into P total we are getting. Why? Because chi A plus chi B is equals to always 1. So then finally what we got? PA plus PB. Some of the partial pressures is equals to P total we are getting. Means Dalton's law is proved. All of you understood? Yes. Now we are discussing one small definition, nothing but aqueous tension. Aqueous tension. Aqueous tension is denoted by letter F. See, what is the meaning of aqueous tension related or based on Dalton's law? Just once you see. Generally in labs or laboratories, we are preparing, we are collecting or we are preparing gases over the water. Means, yes, we are preparing a particular gas. The gas can be collected on the surface of the water. Means, for example, in one experiment, you got one particular gas. This is nothing but which one? Water it is. Now, what gas you prepared? That gas we are collecting on surface of the water. Now, my question, this gas is completely dry gas or moist gas? Is a moist gas we are getting. This is nothing but moist gas. A concept understand carefully. Now pressure, yes, that gas creating some pressure. Pressure of moist gas is equals to, how you are getting in that, what will be there? Gas is there and moist is also there. Together is calling as a total pressure. That's why, yes, in that pressure of dry gas, purely gas pressure, and also pressure of moist. Yes, whatever gas will be here, that is somewhat wet gas. Wet gas means in that pure dry gas is there and also moist will be there. Okay, together pressure only calling as moist gas pressure. So then write down pressure of moist gas is equals to pressure of dry gas plus pressure of water vapor or moist only we are calling as aqueous tension, nothing but F. I want to get the aqueous tension, nothing but F, or nothing but pressure of moist in this is nothing but pressure of moist gas minus pressure of dry gas. This is the formula for aqueous tension. What is the meaning of aqueous tension? Pressure exerted by the moist in the moist gas. Pressure exerted by the water vapor or moist in the moist gas is calling as aqueous tension. Now my question, I taken this liquid at 25 degrees Celsius temperature, then moist will be less, means aqueous tension is less. If I taken same mixer at high temperature like 50 degrees Celsius temperature, then more water converting into gas means more water vapors is there, creating pressure will be high, aqueous tension will be high. That's why we are telling aqueous tension F is directly proportional to which one? Temperature. As the temperature is increasing, evaporation of the water is increasing, evaporation is increasing, creating pressure increasing, the creating pressure by water in this composition is calling as aqueous tension. Did you got my point? Yes. All of you see further and very important things we are discussing here. Listen carefully. Is very important. I think the same concept will be repeating in the physics also. The very important thing. What is that one? Kinetic molecular theory of gases. Kinetic molecular theory of gases. Molecular theory of gases. So what are the kinetic molecular theory of gases is shortcutly called as KMT, kinetic molecular theory of gases. So what is this kinetic molecular theory of gases? It's a very important thing. Understand so many postulates is very important. CET and NEET point of view. One by one we will discuss the first point. You take a gaseous matter. You take a gaseous matter. You should take in the gaseous matter or gas you taken in a container. Yes. In this gaseous matter, what will be there? So many small particles were there. Those small particles only we are calling as gas molecules. What is the meaning of? Yes, in a gaseous matter, the matter is made up of so many smallest particles. Those smallest particles is calling as a gas molecules. Now next point we have to discuss between gas molecules. Between gas molecules there is no force of attraction, and as well as no repulsive force. Means whatever gaseous matter you are taking, in that so many smallest sized particles is there, they are calling as a molecule. But what they were telling, between the gas molecule there is no attractive force, there is no repulsive force. Means what happening, gap between molecules is high. The gap between molecules is high. Okay, automatically what happening, molecules moves randomly. Molecules moves randomly in all directions. See, every point is very important. In this gaseous matter, the molecules will not having any force of attraction or any repulsive force, and that's why the molecules are very far away from each other. So that's why the gas molecules moves randomly in all directions. Are you understanding? And next point we have to discuss the motion or momentum. A motion of molecules, the two gas molecules is not affected by gravitational force. Yes, you can take a perfume bottle. If you can take, yes, if you can press the perfume, what happening? The perfume is moving, means we are feeling the perfume smell, means gas molecules is moving. So this momentum of gas molecule is not attracted by or not affected by gravitational force. If gravitational force is too much on that one, the smell will be stops here only. Why? Because the smelling particles is pulled by gravity. It's not there. That's only is telling the motion or momentum of gas molecule is not affected by gravitational force. And we have to discuss one more thing. If you take a sample of a gas, in that some molecules will be like this. Okay, now compare, for example, this is the 10 liters container, 10 liters of container or vessel. Okay, now you bring them very close, means what happening, the molecules are very close to each other. This is 0.0001 ml of gas. Yes, observe very carefully. The volume of a gas molecules is it considerable compared with volume of the vessel? No. Why? Volume of the vessel will be very high. But volume occupied by the gas molecule is very less. That only we are telling volume of gas molecules. Volume of gas molecule is negligible. Volume of gas molecule is negligible compared with volume of the container. Volume of container. Yes, compare with 10 liters. Yes, you are taking in this room, you are leaving just 4 molecules you are leaving. Yes, the 4 molecules you bring it close together, that's calling as volume of gas molecule. Volume of gas molecule is very less compared with volume of the room or container. That's why compare with volume of the container, volume of gas molecule is neglected. That's only we are telling. Are you getting or no? Next, I will tell you some other things. These are nothing but gas molecules. Okay, we will see some other points. Next point is very important. The gas molecules. Gas molecules collisions are perfectly elastic. Sir, what is the meaning of perfectly elastic? Listen very carefully. If you take one more thing, I want to tell you, whatever gas molecules will be there, the gas molecules speed or velocity is changing within fraction of seconds. Within fraction of seconds. Why like this, sir? Why the molecular velocities will frequently changing? Yes, why? Because the molecules will not having any force of attraction, they are moving randomly. For example, you take a molecule, for example, having 5 meters per second, but what happening within fraction of second, it is colliding with another molecule. While colliding with another molecule, it may exchange or it may transfer energy to another molecule. Automatically velocity of the molecule may going on increasing or decreasing. That we are telling the gas molecule speed frequently changing or changing within fraction of seconds. Now my question, whatever gas molecular collisions will be there, they are perfectly elastic. What is the meaning of elastic? Elastic means what? Yes, if you taken two rubber balls and it will be collide. What happening? While colliding, okay, one molecule speed may increase, another molecule speed may decrease. But is there any damage of the balls? No, same thing. there is no damage of the gas molecule, means there is no combination, there is no breaking. That only we are telling. If you take a gas molecule like this and collide with another gas molecule, nice concept is there, see carefully. For example, this is having 20 kilojoules energy and this is having 50 kilojoules energy will be there. Now it is collide together. While colliding, what happening? The molecule shape may be changing while colliding. After collision, what happening? Energy exchanging will be, energy transfer will be taking place between the molecules, means someone will gain, someone will be losing, something is happening between them. Finally we are getting same shaped molecules we are getting, but this is becoming 30, this is becoming 40. Means what happening? From this molecule to this molecule, what happening? 10 kilojoules energy is transferred. Okay, these type of the collisions is calling as a perfectly elastic. Whenever gas molecules are collide with each other, while under contact the shapes of the molecule may be changing. After collision, the molecules will re-attain or regain its original shape. But in this collision, energy transferred from one molecule to another molecule. Did you observe initially together how much energy is there? 70. Finally also they are having 70. In these collisions, is there energy losing or gaining? No. Means in these collisions there is no energy losing or energy gaining, just energy is transferred. Such collisions only we are calling as elastic collisions. Such collisions we are calling as elastic collisions. Yes, while colliding, energy transferred, but not totally losing or gaining, just transfer one molecule, but overall energy of the molecule will be remaining same. That's why we are telling average kinetic energy, velocity or energy will be same, means average kinetic energy. Average kinetic energy of gas molecules is remains same before collision and after collision, and this average kinetic energy of gas molecule is directly proportional to absolute temperature. Absolute temperature. So that only write down here, Ke average kinetic energy is directly proportional to capital T. Yes, as the temperature is rising. So if you taken the gases sample at a constant temperature, the average kinetic energy will be remain same. But you rise at the temperature, what happening? The supplied energy taken by the gas molecule raising its kinetic energy, overall kinetic energy will be going on increasing. That's why average kinetic energy is directly proportional to temperature. Just once again I want to discuss the points as very important. According to kinetic molecular theory of gases, if you take any gaseous matter made up of so many smallest particle called as gas molecules, between the gas molecule there is no force of attraction, there is no repulsive force. Thus why the gas molecules maintaining much gap between one another. Thus why molecules moves randomly in all directions. Okay, motion of the gas molecule cannot be affected by gravitational force. Okay, that's why the gas molecules moving from one place to another place with high speed. And compare with volume container, volume of gas molecule is negligible. Just I shown very clearly, I taken 10 liters container, but in that only 0.001 ml of gas is there. That's why it's neglected. Now we can take the gas molecule collisions are perfectly elastic. What is the meaning of this one? While colliding, the shape may deviate. After collision, again they are gaining original shape. In this process, energy transferred from one molecule to another molecule, but average energy will be maintaining constant at that particular temperature. That only I written here. Average kinetic energy of the gas molecule will be remain same at that temperature. But as the rising temperature, average kinetic energy is also increasing. That's why average kinetic energy is directly proportional to absolute temperature. Did you got my point? Yes. We will discuss some other important postulates of KMT. The very simple and very important also, but we have to observe very carefully the things. See some other postulates of kinetic molecular theory. Yes. Next point, is nothing but if you take a gaseous sample, in that gaseous sample molecules will be there. What molecules will do? The molecules moves randomly in all direction. Then what happening? The molecules may collide with each other, and the molecules may collide with the inner walls of the container. Due to this one, pressure will be creating. Now in gaseous matter, a collisions between gas molecules, generally collisions will be happening between the gas molecules and also between gas molecules and inner walls of the container, container. Yes, this is very important point. Actually, if you take any gaseous sample, in the gaseous sample the molecules moves randomly in all directions, then two types of the collision is possible. One is between the gas molecule, another one is between molecule and inner walls of the container. In this one type of the collision is neglected. What? Between the molecules is not considered. Why? Between the molecule there is no force of attraction, there is no repulsive point, he told. That's why the collisions between molecule and molecule will be very less force. That's why the pressure is not considered. Then pressure of a gas is only because of collision between molecules and inner walls of the container. Yes, pressure of a gas is due to collisions between molecules and molecule with inner walls of the container, inner walls of container. Yes, between the molecules also collision is happening, but they are not considered. Why? Because force of attraction will be very less, created pressure is negligible. That's why pressure of a gas is directly proportional to number of collisions between gas molecule, collisions of molecule with walls of the container. Yes, so compulsory the pressure of the gas is directly proportional to number of collisions of a molecules with walls. More collisions of molecules with walls, more pressure will be creating. All of you understanding? Yes. Now we have to discuss one more thing, is nothing but KMT, means kinetic molecular theory equation. Is a very important amount. After concluding all these things, they proposed one thing: PV is equals to 1/3 mn c square. What is the meaning of P? P is nothing but pressure of a gas. You know very well. V means volume of a gas. And what is the meaning of M? What you are expecting, it will be wrong. M is nothing but mass of a single gas molecule. Generally we are expecting mass of the gas. No, mass of single gas molecule it is. Mass of single gas molecule. N means you are expecting number of moles. No, in KMT N refers number of gas molecules. Number of gas molecules. Sir, what is the meaning of C? C means speed. Speed means is calling as RMS velocity. What is the meaning of RMS velocity? I will explain briefly furtherly. Don't worry about that one. What is the kinetic gas equation? Kinetic molecular theory gas equation? PV is equals to 1/3 mn c square. Pressure, volume, M a mass of a single gas molecule, N number of gas molecules, C means RMS velocity. Now we are discussing some important point. This one, yes, after this one, a gas which obeys all postulates of KMT, kinetic molecular theory, then the gas is calling as a ideal gas. but no gas is like that. No gas is like this. That's why what we can tell, no ideal gas in the universe. No ideal gas. But whatever gases we are discussing, all gases are real gases. All gases are real gases. What is the point? The gas which obeys all the postulates of the kinetic molecular theory, what we discussed right now, gas which is obeying all these, they are calling as ideal gas. But no gas is like this, means no gas is obeying all these conditions. That's why no ideal gas. Whatever gases we have, all are real gases only. Like that, in the universe, no one is a perfect man. Everybody has some negatives in it. That's why I am perfect, I am super, don't feel like that. All are having some negatives in them. We have to try to rectify them. Then only you are almost becoming like perfect, but not perfect. Same thing. So all are real but not ideal, or means all are real but not perfect. Are you understanding or no? Based on this one, I want to discuss some important concepts. See, average kinetic energy. Average kinetic energy of gas. What is the meaning of average kinetic energy? Kinetic energy of 1 mole of a gas molecules. 1 mole of a gas molecules. Yes. The kinetic energy of 1 mole of a gas molecule is calling as a average kinetic energy. So very important, average, yes, all together. So total energy by number of molecule is calling as a average. So average kinetic energy means kinetic energy of 1 mole of a gas molecule is calling as a average kinetic energy. We will study. First of all, generally kinetic energy means formula of mv square. Okay, generally apply to the gas of v means I am writing as a c. Why? Because anyway velocity or c, both are same meaning. Now this is the kinetic energy of a single molecule, but I want kinetic energy of 1 mole of the material, then only we are calling as a average kinetic energy. So average kinetic energy means what? Of into m into Avogadro number into c square. A single molecule kinetic energy is this one. 1 mole means into Avogadro number. Avogadro number of the particle mass only we are calling as a molecular mass. That's why average kinetic energy Ke average is equals to of, I will write capital M here. Why? Because capital M means gram molecular weight. Gram molecular weight means Avogadro number of the molecule's mass. Mass of the gas molecule. Avogadro number of the gas molecule, mass of the gas molecule. Avogadro number of the particle mass only we are calling as a gram molecular weight. That is only nothing but capital M. Can you write it here? No problem. So now we can take, this is the average kinetic energy of mc square. Take it KMT equation, kinetic molecular theory equation. What is that one? PV is equals to 1/3 m n c square. This is the n number of molecules into mass. But I am taking which one? 1 mole I am taking. 1 mole of gas means n is equals to Avogadro number. N into n is nothing but Avogadro number. Avogadro m means what? Single gas molecule mass. Then Avogadro number of the molecule mass means what you are getting? You see PV is equals to 1/3 m into Na into c square. Just we written no. M into Na is nothing but molecular mass. PV is equals to 1/3. Avogadro number of the molecule mass is nothing but gram molecular mass. PV is equals to 1/3 mc square. We will see some other things. PV is equals to 1/3 mc square from KMT. Then write down PV is equals to 1/3. I am doing 2 into mc square by 2 I am doing. Means into 2 by 2 I am doing. Is there any problem? No. Then PV is equals to 2 comes front 2/3 into of mc square. half mc square means what we can write from here, kinetic average. So PV is equals to 2 by 3 of average kinetic energy AVG. So then separate average kinetic energy is equals to 3 by 2 into PV. Then can we write KE